anxious, but I don't think so. No. Restored church on Sunday. Apps are on, or sermons are online. It was good. She went hard.
They always go right.
That's such a good way. If any of you guys are like, I've gone to church multiple times and it just doesn't do anything for my heart, come to church with us some Sunday. You are always invited. Love to have you.
It's really good. You want to feel bad. Not like that. Like it'll never mind. I'm gonna stop talking to you.
If you want to see the practical application of Christ and the gospel in your life. In a way that hurts sometimes, but then, oh, so good. All right. You're always invited. That's Rashida and Plummer. We'll go get lunch afterwards. I'll buy. Or maybe we'll have Mr. Corey buy. Just kidding. We're on number 16 and beyond. What do you guys have? Page 8.
I think we actually did this one because I remember you did.
I went over the 18 one. Yeah, were there any other ones besides 18? Ooh, what do you guys see? You talk it out. What do you see on 16? Aw, man, it's almost a geoseries. What if the plus 4 wasn't there? Wait a minute. If it was geoseries, it'd be 3 over 2. Isn't that bigger than 1? Wait, isn't the top stronger than the bottom?
No, isn't it tied?
3 to the n instead of 2 to the n?
What? I don't know. I thought it was tied.
Either way. All right, fine. You could do a limit comparison, which is what I would have done with 1 over 3 halves to the n, because then that would be GOR is greater than 1, so then divergent. And then when you take the limit, wouldn't the limit be 1? When you compare to 1 over 3 halves to the n? Well, that's what I thought, but...
And then the limit will equal 3 over 2, which is not equal to 0, so it's divergent.
Oh, sorry. You guys didn't like that I said the word stronger. Yeah, I was saying nth term test, it fails. Divergent. Sorry. I was saying stronger as in, it doesn't even matter. It's non-zero, right? It's non-zero. But I was saying you could also compare it to, if you really wanted to, 1 over 3 over 2 to the n, which is GO fails, R is greater than 1. When you flip it, it's going to have a limit of 1. What one does, the other does. But yeah, nth term test works too. Well, just because the idea, Aryan, though, like it's the same thing as number 18. If you peel away the pluses and think of what's left as far as degrees, you can almost always do limit comparison. So I was just kind of following like a general trend.
Question for 16 though, 3 to the n is greater than 2 to the n, like power-wise?
It's bigger numbers, but as far as degree, no, it's tied.
Okay.
Yeah. We good on page 8? Page 9?
Oh, wait.
20B.
Oh, so page 9, right?
20B, C, and D.
Why did we all read out? You guys are so cute.
Understand what
I can do B.
Wait, hold on. What's going on this whole thing? What are the directions?
What is the sum?
What is the sum, which means you can find it. Who can do A?
Oh, I can.
Oh, it's so easy. Who can do B? Take it, Aryan. Who can do C? Maggie, take it. Who can do D? Sally? Oh, go do A, Riley. Who wants D? Kathy, do D. Sally, go up and help. You can inspire.
Yeah.
All right, as they're playing around with finding the sum, what else do we have on questions on this page? Anything?
Sally, just so you know, I haven't done this. Okay, I don't know what to do.
Are you doing D? Yeah. That was garbage.
Okay, well, let's do it.
It was so bad.
What? Wait, did you do it everyone?
Yeah, you can do it over here, guys.
I'm ready.
You guys are hilarious.
Telescope, right?
The honesty, the vulnerability, I love it. All right, the rest of you guys out there. Where else are we stuck? Stuck on 21? Yeah. Yeah. Oh, yeah. I think I did it quick yesterday, not very long. What I was telling Aryan a second ago, when you see especially polynomial expressions with pluses and minuses and blah, 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 always think limit comparison. Because degree tests, we always look at the strongest guys. And so I would think 3 to the n over n to the 5th, which reduces to 3 over n to the 4th, right? The 3 is just a constant. He doesn't really have much bearing. So I would compare him to, from me looking at these two guys, taking out an n, and then just disregarding the 3. And the reason I would compare this, besides what I just mentioned, well, thinking about what's going on here, isn't that same thing as n squared? P series, P equals 2 greater than 1, so convergent. And then when I flip this guy, I'm going to end up with the nice thing is if I do this little analysis, the reason I did the square root is so it could be brought in. Check it. That's going to be an n to the 5th over an n to the 5th. So degrees are tied. So I can say the limit is equal to technically the ratio of leading coefficients, which you have to put a root on it, which is greater than 0. So what one does, the other does. Does that make sense? But that's how I analyze it. And that's technically what I was doing here when you guys thought I was going extra, like I was. But I was like, well, you can ignore the +4, think of who's left, and then compare to that, analyze that separately. Just this one was weird because of the square root. I had to put a square root around it all. And then just considering the highest degree terms helped a little bit. Going back to page 9, do you guys have anything besides number 20? I can walk around to make sure everything looks good. You guys okay on 21? Yeah? Okay. We're going on to page 10 in just a second, but let me pause to make sure everything makes sense. C is a telescoping. So as you're like zoom, 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 zoom on number 20, 1/2 and 1/3 will never get canceled out. You're doing minus the limit of the second piece, because as you get to a new piece, once things start canceling out, it's the first guy that cancels out with a prior guy. So every nth term, the first guy cancels and the second guy is left until a later term. So when you get to this guy, somewhere down the line, and as soon as you write 1 over n plus 1, he just canceled with something before. The 1 over n plus 3 is chilling until a later time, so that's who I'm taking the limit of. That goes to 0, and 1/2 plus 1/3 is 5/6. Number 20b was a geoseries. You had to kind of rewrite it, though, didn't you? Oh, it's not up there anymore. You had to rewrite it a bit, because the negative n flips the orientation of it. But still, once you flip it, they were trying to totally be tricky on you. But once you flip it, now you can see your r. Remember, positive, negative doesn't matter as long as the magnitude is less than 1. Then you just need your first term, which some of you might not have even thought about expanding. Huh. Did it start at n equals 2? It did, right?
Yeah.
Oh, I didn't plug in n equals 2. Sorry. I saw it and I didn't plug it in. So that'd be 1/2. Yeah. So 4/9. There you go. And then you would keep going from there to negative, 8/27, etc. First term is what always goes on top. 1 minus the negative will be adding and then simplifying your complex fraction. Riley's is back here. The weird thing on this one might have been that the 3 wasn't changing. Like if you guys had messed up, like in the sense of considering what's going on, it's 3 times 1/2 to the n. So some of you might have accidentally put 3 over 2 as your r instead of 1/2, but just 1/2 is the component or the piece being raised to the n. Your initial term was 3, so then plugging and chugging will get you to your final, if you were to simplify it, of 6, yeah? But 3 over 1 minus 1/2 is perfect. Good. And then D, I heard, was a bit nasty. Because it was telescoping, but not in partial fraction form yet, right?
I didn't know how to do that.
Is it harder than the cover-up method?
No, it was like it just like taking like setting it up.
Oh, they solved it the other way. I think I would have done. Because you could have done thumb trick with +1/2 and -1/2, right?
What did they do?
They did the multiplying way. And then solving systems of equations. No, plugging in negative a half and a half. Negative 1/2 would make that 0. Yeah. I think they plugged in the zero method, but we didn't go over the zero method much this year. So plugging in n is negative 1/2, you end up with b equals. And then plugging in n is positive 1/2, you end up with a equals. But you could have done that with the cover-up method too. Plugging in negative a half. Sorry, positive a half, negative. And then what they're doing right now, you guys can see that they're analyzing just like, just like this one. Because for every telescoping, you have to start expanding. Like, I don't know any other way to do it. Start expanding and ask yourself, who's left? Who's left behind? Because those are both components that will never cancel out, will be part of the sum. And then figure out what part of the nth term is chilling and sticking behind or is waiting. Take the limit and solve. So then what you watched them do is they went ahead and had to figure out who was there and who was stuck. Oh, because 3/2 was in front of everybody?
Yeah. No. Yeah.
Careful. AP guys could have taken off a point, and it would have been so sad. But you girls did a great job. You just need to, when you put that equals, you have to write that 3/2 in front. Does that make sense? Otherwise, the equals wouldn't truly be an equals. Or you could, if you wanted to, instead, if you didn't want to, because you would also have to like put in brackets the entire thing. You could just do like a brace, and you could just worry about this and then bring in the 3/2. Just don't do an equals, and you'll be all right. Good. The limit of the last piece goes to 0, so poof, he's gone. Okay. We're now to page 10. Anything? Yeah. Oh. This is mean. Power to a power you multiply, right? Okay. So,
Do we have to do like an explanation, or can we just say like the square because it's already gone?
well, I'm just trying to show that that's true for those that didn't see it. Isn't to a power a power to a power you multiply? So whenever you have an alternator to the 2 anything, guess what just happened to your alternator? It's a positive 1 to the n. They were being mean because they wrote the negative 1 squared instead of a positive 1 to the n, which would end up just being a sub n. Now, you have to think about what's going on with a sub n, but 1 to the n doesn't have any bearing whatsoever. So then we have to think about, okay, who is a to the n? He's conditionally convergent, which means he's only convergent because of his alternator. So take away his alternator, and what is he? If he was absolutely convergent, he would still converge if you take away the alternator. But since he's conditionally convergent, take away his alternator. He won't converge. Letter C?
It's because the original convergence.
Yeah, that's exactly how they recorded it.
If the series a sub n is conditionally convergent. Oh, my bad. Sorry. I get it. I thought there was, yeah, if there was a negative 1, then mine would have been fine. Lo siento. You're just looking at a sub n, yeah. Conditionally convergent is convergent for all of you who just like, is she lying to us? No. Conditionally convergent does count as convergent. Sorry. The additional alternator that would have canceled out the original alternator but actually had no bearing because he was being squared. Didn't change anything. Okay, anything else on page 10?
23D, I have a question. You can just use G as your
Why?
Because just being negative E over time.
Pi and E are just numbers, and pi is 3-ish, and E is 2-ish.
And then so do you have to like work it out, or can you just say like that's absolutely
You can say pi over E is greater than 1. Pi over E?
E over 5?
Wait.
It's what, because it's negative.
Oh, I didn't read the whole thing. I just saw the pi and the E. Sorry. So the negative would flip it, so e over pi is less than 1, so therefore it's convergent.
And then you don't have to find like the.
No, it didn't say find the sum.
Gotcha.
Yeah, so you're okay.
For E, what would you just have?
What I'm seeing in my head really quickly, besides the alternator that's right there, is I'm seeing these are the two highest degrees. So in my head, I would compare to a 1 over root n, because then root n tie, the limit is 1. Now careful, that's limit comparison.
So one doesn't ever go so
Limit comparison is for positive terms only, right? So I'd have to be considering the absolute value. Why am I making a big deal about that? Because if I get, as the other does, 1 over square root of n is p series divergent. So all I figured out is the absolute value is divergent. Does that tell me anything about whether or not the alternator could converge? No. So therefore I have to come back and consider the alternator, but in that case, just consider your steps 1 and 2. So step 1, yes, the bottom does win, so therefore the limit goes to, the limit to infinity equals 0. And then step 2, as you continue to expand, the n plus first will be less than the nth. So yes, conditionally convergent. Yeah. Technically, the alternator is the negative in front of the pi over e. Or, since he's geo-series, I don't mind negatives because they can be positive or negative r's. So then I don't actually have to worry about, oh, I see, Riley, because you're trying to think of conditionally or absolutely, right? Okay. So to consider the absolute value, yes, you would disregard the negative. And the next thing is e over pi also converges. So the positive negative didn't make a difference. The less than 1 made a difference. Yeah. So you could still kind of just use geo to get there, but yeah.
You don't have to go through the whole thing.
If it's convergent by another test, you could say absolutely converges. Yeah. Like the geo series with a negative, if it converges, it will be absolutely convergent. Yeah. That's good. How are we on page, what are we on, 11?
Yeah.
Number 12? Or page 12, 27, 28? You guys just go with whatever your next question is then. Do we have a next question, or are we done? Yeah, Diva. 24. Okay, as soon as you see interval, and actually this is really good for chapter 10, guys, because we're going to be exposed to other error beyond alternating series. So it's important to have the alternating series error down, because then when we introduce other, like the Lagrange error bound, you have to read a question and be like, wait, are they talking about alternating and the remainder theorem, or are they talking about this other one? So this one, S2 is used to approximate S equals 4 over n squared, which interval gives an upper and lower bound. Ooh. There's no stink. Did I give you this one too early?
I got it right. If you use the same thing as the alternator.
I'm just checking his key as to what he did, though, because he might have gone illegal on this one. What is this number? And you guys don't see an alternator anywhere, right? Like, I'm not crazy? Diva, this is 24, yeah?
Yeah.
Ooh, nasty. Yeah, he admits it's a p-series because it doesn't converge by alternating. Why did he use the alternator remainder theorem? This one, if I were you guys, I'd put big old parentheses around because we have not talked about error for anything except for alternating. So I think he's pulling from our chapter 10. I mean, I see that you guys are like, oh, let's go to the next term. I just don't want you to have that in your brain that that's what you always do. That's dangerous. No. It makes sense because, I mean, the question is error of a sample. I'll put the old parentheses around 24. Thanks, Diva. Any other questions on the packet? I'm just going to say the whole packet. Sally? 27? Yeah.
That one's sick. He's trying to trick us.
What do you mean? How are they trying to trick us?
He's like trying to like make us scared.
Because what are you supposed to do? Why L'Hopital's, though? I heard it. It was quiet. Say it again. Yeah, it's not in a series, so we can literally just chug like an old limit, right? So then if you plug and chug, then you get 0 over 0, which then lets us go ahead and go to Maggie's L'Hopital's, right? And we didn't do as equal. We didn't do anything illegal. It's a multiple choice anyway, whatever. L'Hopital's. How do I take the derivative of an integral? Ooh, FTC part. Or R part 1, whatever. Derivative of an integral. It's f of u times u prime. You just plug in that guy, and if he has a prime, you multiply it. But he doesn't, because his prime, well, he does. His derivative is 1. But we end up basically with e to the x squared all over 2x. It's a nice number of e over 2. Tricky, tricky, tricky. Yeah, since it wasn't in a series, it was just like a plug and chug and go. Nice. Nice. Anything else in the whole packet? For what integers will both... Ooh, this is such an AP question, right? Why? They like, yeah, to give you A's or C's or K's or maybe C's and K's or B's and K's and go find them. Nasty. And now it's with series? But what do you need? Both of them to converge. Right away, be like, funny. I just my chances to 50-50. Whoa, whoa, whoa. How do I improve my chances from 20% to 50%? Why can K not be an even number? Plus 1 over n diverges. So right away I knew it couldn't be an even number. But then I have to figure out odd. Oh, wait a minute. Hey, this is Geo, and Geo I need my R to be less than 1. So it has to be 3, not 5. 5 would be greater than 1 divergent. Is that cool? Oh, sorry. Did the even number make sense? Because then it'd be a positive. Then I had between 3 and 5, so I looked at him. This is a Geo series, R to the n. And I couldn't have 5/4 because if R is greater than 1, divergent. I needed 3/4, less than 1. There you go. All right, I think with that, packet. Pass it up, pass it over. Long story short, get it up there by the end of the day. Are we good? Just in case a couple of you?
Yeah.
Okay. If there are people ready to go, someone just be a friend and grab them and go put them up. On top, CalcBC. I'll take it by the end of the day. I don't really mind.
Oh, sorry, James.
Yeah. Whew, we can finally go to section 10.1. Yay! So excited. I'm going to blow your minds today. You ready? I mean, I'm trying to be excited. I'm excited. Did you guys plug in the X for R yesterday? Yeah? Hold on, wait, real quick. Quick reminder, since we've been talking about geoseries through that whole packet, off and on. When does a geoseries converge? Good, so it converges to, it has a sum. The magnitude of R is between 1 and -1, right? Diverges if positive or negative is having a magnitude greater than or equal to 1. Are we good? So what happens if we plug in x? So a plus ax plus ax squared plus ax cubed plus ax to the n minus 1. Oh, that's not all that exciting. All you're saying is we can keep on making a bigger and bigger and bigger polynomial and write it in sigma notation. Is that all I'm saying? You just saw your first power series. Whoop. times x times x times x times x, your first power series. It's a series of powers, not exponential functions. Exponential would have a variable in the exponent. Power functions are basically just big old polynomials. So how on earth are they used, and what are they actually useful for? Well, that's a better question. But for right now, did we just see that any infinite polynomial that literally times x times x times x is technically a geoseries? Where x is r and r is x? First, we'll do a quick review of geoseries. Geoseries formed by multiplying by the common ratio r. Suppose I told you to start with a sub 1 equals 2 and let r equals 3. What geoseries would you write? What would you write? A sub 1 is 2, r is 3. What? Hold on. What geoseries would you, yeah, what's the actual series?
Oh, we're writing this. Wait, why isn't it negative?
Wait, where's the negative?
Oh, wait, I'm looking at.
Look up. Times 3, times 3, times 3, times 3. How can we write this as a sigma? Why am I going to say minus 1? I don't want a 1/3, not 1/3, sorry. I don't want a 3 yet, right? I need a 3 for the second term, not a first term. Is that okay? Yeah. Okay. True? Is it okay? Okay, how about the next one? Now, Maggie. 2 minus 6 plus 18 minus 54. Are we good? What would our nth term be? Is that good? So couldn't I rewrite this one to be minus 1 times 2 times 3 to the n minus 1, which they probably wouldn't do, but isn't it technically the same thing but with an alternator?
Yeah. Okay, so series as
At 0 with an n?
so yes.
Yeah, no, that's perfect. Yeah, that's good. There are multiple ways of writing it. That's good. So then what about this one? What if a sub 1 was 1 and r was... So what would that be? Middle school PE is my guess. What if a sub 1 was 1 and r was equal to x? I get an infinite polynomial? What would the sum be? Oh, we missed a part of the problem. What would the sum be in this case? What would the sum be up here? Why not? This one's divergent. Why? This one's divergent, right? Because r is less than negative 1. So what can I say down here? Divergent? Well, not necessarily. Who's your r? X. So an infinite polynomial will converge to something as long as Isn't this the guy that we can actually do stuff with? So he is the infinite sum as long as I'm looking at x's in between 1 and negative 1? An infinite polynomial, all bound in one little rational function. So this rational function could be expressed as an infinite polynomial? Wait a minute. Hold on. What if, I think there's an actual question. Is there an actual question? Oh, I don't want to show that yet. Where is he? There he is. Let me go steal him. Who is this guy? Who is 1 over 1 minus x? He's a rational function. He has a vertical asymptote at 1. Probably somewhat follows the behavior of 1 over x in the sense of like he has a curvature this way and that way and the other way. Maybe? Is that a thing? You guys can't totally read it. Let me zoom in on it, and then I'll go ahead and zoom out. Single page. Find the power series for 1 over 1 x under x equals 0 by Taylor's rule. You don't know what that is. Manipulating a geometric series. We kind of talked about it. Long division. Here's what I want you to do. Come back. We'll come back. Long division. Why would we have never done long division on this guy up until this point? Why would we have never done long division? It's not top-heavy. It's not improper. Ooh, but we do long division when we have top-heavy, when we have improper, especially with partial fractions and integration, right? Just nod and say yes. So, why am I saying do long division on an improper? No, he's not improper. He's proper. He's not top-heavy. Can I divide 1 minus x by 1? What do I get? Oh, it's easy. I just do 1, then I do 1, then that cancels, and then I have negative x, and I do negative x. And then I can do...
This is like physics yesterday.
Wait, isn't 1 supposed to be on the inside?
Why?
Because it's on top?
Good. It's okay. I know, that's the scary part. How do we do long division? Don't we usually have the polynomial in here and the constant out here?
Yeah.
But what's going to happen if we properly long divide? That's proper. That's legal. The other way was what we're used to because we always had the bigger guy inside and the smaller guy outside. But proper division, he goes in. Okay, so how many times does 1 go into 1? Oh.
I'm so confused.
Now what? How many times does 1 go into x? How many times does 1 go into x squared? How many times will 1 go into x? Are there other things that are actual like functions that we use every day that could be an infinite sum of something else? Why on earth would we want this guy written like that? Glad you asked. I will try to make chapter 10 answering that question. Let's talk about interval of convergence. Let's talk about interval of convergence. Let me get back to one page.
Maggie's like, sure. Why not? Might as well.
I think we have another Endeavor card coming pretty soon. That's going to have a few more than just this one.
Wait, this is a forever card?
Part of it. Don't make it one yet.
Should we write that top part down?
Yeah, it's a good idea. It's kind of important. He's actually the best power series because he's the simplest. You just go times x times x times x times x.
The complicated ones.
Oh my gosh, those kids sound like they're dying.
Maybe they are. It's okay. There's a teacher outside. They'll figure it out. You know what's crazy? What if I was to change this to 1 over 1 minus x squared? You guys know that it'd be 1 plus x squared plus x to the 4th plus x to the 6th plus x to the 8th plus x to the 10th? What if I had 1 over 1 minus 2x? Do you know that it'd be 1 plus 2x plus 4x squared plus 8x cubed plus... I can make all sorts of power series as long as the guy looks like this. Huh. Interval of convergence. We can call it the IOT. Interval of convergence. It's all based on, even though you're going to be having to remember it with power series with x, it's all based on geoseries. Because it's as simple as the absolute value of x has to be less than 1, which means x has to be in between -1 and +1. Which is why I started off this section saying, hey, remember geoseries? Now, not all power series are the idea of power series come from geoseries. But there are going to be others as well. Explore with Grapher. If only my graphing software was up. Mrs. Grishams has been working on it, but I can't quite pull it up yet. One graphing calculator per group. Can we try? Here's what I want you guys to do. I want you to graph y1 is our 1 over 1 minus x. y2 is equal to 1. y3 is equal to 1 plus x. y4 is equal to 1 plus x squared. y5 is equal to 1 plus x squared plus x cubed. y6 is equal to 1 plus x squared plus x cubed plus x to the fourth. I guess we'll stop there. That's a good question. Do you know what you're doing? Oh, yes, you do. You're just putting stuff in your y's and being like, oh, I'll just go try it. That's what you're doing. How much does 1 over x look like y equals 1? It doesn't. Except at 1. Or how much does 1 over 1 minus x plus x? It doesn't. How about 1 plus x squared? How about 1 plus x squared plus x cubed? How about 1 plus x squared plus x cubed plus x to the fourth? Do you see anything cool happening? Before you hit the graph button, have it face your group. Before it hit the graph button, your graph should be graphing sequentially, which means graphing the first and the second and the third and the fourth and the fifth and the sixth. Before you hit the graph button, face the group. But what's going on as you get closer and closer? If you zoom in 2 times, zoom in, enter, then watch our graph again. Now take everybody out but the y6. Take everybody out but the y6. Nope. Keep it zoomed in. Do you guys see that ladder polynomial, which is a 4th degree polynomial? Do you see it skimming, not just at one point, but seemingly for an interval? Do you see it skimming for like an entire interval? Yeah. That one crossed through at one point. That one crossed through at another point, but at a slant. That was a little bit better. That one kind of like hit for a second. That one hit for a little longer. That one hit for a little longer. What's going to keep on going as I keep on adding terms? The curvature for a certain interval is going to keep getting closer and closer and closer and closer and closer to where the curves are the same. Theoretically, if you could have the infinite sum of all the different polynomials. Now, wait a minute. No, but it's not the exact same. No. It's the exact same on this interval, but is it the exact same for the whole thing? No. It's not the exact same for the whole thing, but it is the exact same for a certain interval of convergence, or it's at least getting closer and closer and closer and closer. Why would you want to approximate a rational function with a polynomial? What's a power series? Representing rational functions as geoseries, basically. Why would you want to represent a rational function as a series? Basically, you can take any infinite polynomial we've been talking about. It will be a power series at x equals 0. That begs the question, can you center it somewhere else? Oh, you can center it somewhere else. This one is centered at x equals 0. This one's going to be centered at x equals a. It's going to be centered somewhere else. There's some sort of translation. Oh, yeah, it's moving to the right a, or if it's a negative a, it's moving to the left a. Power series. We're seeing some relationships, rational functions, geoseries, also seen as polynomials. The new vocab, not just power series, but also centered at. It could be centered at 0, like what you guys just saw. So the convergence is right around x equals 0, but that convergence could be somewhere else if we wanted it to be. I would. I think I do have a forever card coming eventually. It's a little ways away. It's a long ways away. Is my forever card coming in this section? Oh, there he is. Anyway. So for right now, yeah. And what you guys just saw was something called a Taylor polynomial and a Maclaurin polynomial. Hannah, you've been practicing your accent. Yes. Oh. But we do have James here.
Remember she always sits like
Yelling at us.
yeah, she shushed me every single day.
You guys were a little distracted.
I did it even kissing.
No, that was really funny.
No, she was
Do you guys have it? The funny thing is, you do have James. You haven't asked him to say look.
I did.
Oh, did you say it?
I don't know what she said though.
Oh. Something about the hospital.
Hospital.
You're going to the hospital. Right? Had something.
She was saying it's going to put me in the hospital.
Yeah. That was it. I couldn't remember what the phrase was. There you go, Meg. You got it. Perfect. I just caught Deba in a really good face, that's all.
I just look like that all the time.
I'm not done.
It's okay. If you guys notice, like I think our entire chapter 10 is called Power Series. It's not like you're going to totally get a power series or the applications of a power series all in this section. And if you guys notice, because I was totally just like going forward in notes, isn't everything left in this section just examples? So we're just going to be playing with examples tomorrow. The integration is net change packet put us a little bit behind, but we'll survive. We're going to bust through examples of 10.1. I have to change around Google Classroom. Oh, I haven't even put it up in Google Classroom. We're good. It's going to be due on, I didn't put it up, Thursday. However, once we get going on this stuff, it's going to be really easy to fall behind. So please, please, please get caught up so that way tomorrow you're ready to go. Go, what do I mean by go? We're not quite ready for that one. We can do this though. Well, is it? Hold on. It's really easy to fall behind. Yeah. Hey guys, if I know, what you guys just wrote, 1 over 1 minus x is 1 plus x squared plus, then what's 1 over 1 plus x going to be? Why? Because can't I rewrite this to be 1 minus a negative x, and I can go ahead and just say function notation, oh, it's 1 minus x squared minus x cubed, etc.? Oh. So what if I have something crazy like this? X over 1 plus x. Couldn't I take this and then multiply everything, distribute by an x? So it'd be x minus x squared plus x cubed minus x to the 4th. Why would we do this? Hey, derivatives and integrals of these guys are so much easier than those guys. I wonder what that's going to mean someday. All right, bye guys. See you later. 10.1 due on Thursday, not tomorrow.
For us to write out the 1 plus, does there need to be a summation symbol?
You could summarize. It technically says the general term. So if I had more time, gone ahead x to the n, 1,
But there doesn't have a summation.
which we could encapsulate. Yeah. But they care more about knowing the nth term than being able to perfectly put it in a summation, which ultimately one leads to the other. Yeah.
What's the form for the APIs?
Does anybody else need an AP form due on Friday?